Okay.
Want to go ahead and start sharing your screen, you're more than welcome. Welcome, everybody. I'll just do a quick announcements and some, uh, uh, forgetting the word. Anyway, welcome everybody to the webinar today. Jason Vandiver with Spear. I'm assuming almost everybody on here has been on before, so welcome back. We do have a new, or at least somewhat new webinar. We've never done one over a house ventilation. Now, we've certainly done the ventilation as required by the energy code, but we're just talking about the attic ventilation with this. And I know me personally, I've been into a ton of underventilated attics, and it's a problem more than not, frankly, in Texas. So looking forward to having Nick on with Corix today. Nick, I'll let you introduce yourself, Nick. A little bit of housekeeping before we get started. To get your ICC CEUs, you'll just, Kathy's on vacation until next week, so give her until the first of the week to send out the course evaluation. After you get the course evaluation from Kathy, simply fill that out and we will send you your ICC CEUs. Again, be patient, wait till the first of next week. With that, Nick, the floor is yours, sir. If you'll just introduce yourself, a little bit about you, and the floor is yours.
All right. Well, thanks, Jason. I appreciate having me on today, and I look forward to kind of sharing some information with everybody. So my name is Nick Noby, and I am the Senior Product Manager at Corix Building Products. So for those of you who have not heard of Corix, what we do is we work kind of on the building envelope is really kind of our sweet spot. So we're a manufacturer, and we develop and sell products that help protect the envelope, really. So there's a couple things there. First is we have our attic protection category, which is primarily what we're going to be focusing on today. That's a lot of ventilation products for your attic space to keep those attics cool and healthy. Second, we do have a wall protection category as well. So that's especially kind of ties into the rain screen systems and creating vented cavities behind walls. Because one of the things we're realizing, especially as time has gone on, is it's important to vent and drain behind walls to protect cladding. So we have a wall protection category, and the last is roof protection, and that's actually keeping those materials up on your roof healthy too. So we kind of play in the building envelope space. Me personally, as our senior product manager, I'm kind of our technical guy. So I'm engineering, testing, and developing new products. That's one part of my job. And the other big part of my job really is I'm kind of our ventilation guru who I go around the country. I do trainings. I get in on a lot of roofs. I've crawled in a lot of attics over the year. And basically what I'm doing is a lot of times I'm diagnosing problems, ventilation problems. And then I also help design ventilation systems for both commercial and residential. So kind of like I really, again, my goal with these presentations is to, help you guys just kind of understand, just share some of my experiences, answer any questions you might have about ventilation, and ultimately just kind of help everybody understand a little bit of kind of what the landscape of attic ventilation is, and hopefully get us all, and hopefully the market as a whole, a little bit more educated, because one of the things that I've found is, and Jason was alluding to it, is, attic ventilation is not done properly a lot. I've heard, I always use the statistic about roughly 93% of attics in the United States are not vented properly. And there's a variety of reasons why. We'll get into those, but that's really the goal of today, is trying to get us more educated so we can kind of get that number down. So with that said, I'm going to jump in. If anybody has any questions at any point, do not hesitate to reach out, whether you want to chime in or if you want to pop something in the Q&A, the message as well, and I'll be happy to either address it kind of when it comes up, or I'll make sure we have some time at the end as well to answer some questions. So what we're going to cover today is kind of how airflow in the attic space works. We'll talk about the balance system. I want to talk about what NFA is, and more importantly, what it's not. And kind of we'll spend the bulk of our time kind of in actual applications and on the job design, specifications, and some specific details about what to look for when you're actually in attics and on roofs. So I like to always start with this quote by Joe Stebrick, who's one of the main experts in building envelope science and attic ventilation. He says, a vented attic is one of the most underappreciated building assemblies that we have in the history of building science. And I like this quote because it's basically, it kind of highlights the fact that, this science and technology has been around for many, many decades. So it's nothing new, it's nothing fancy. There's not a lot of new technical innovation, but it's still one of the most critical components to having a healthy roof and a healthy home. And it's just, I think because it can be so simple, a lot of times it gets overlooked, and there's just a lot of mistakes that can be made with it. So obviously, if you're doing it right, the goal is making sure that you're maximizing the life of the materials that you're putting on. So whether it's the decking, the underlayments, the shingles, the tile, whatever is on that roof, you want those things to reach their peak life. And anything, when you don't have an effective ventilation system, what you're going to be doing is you're shortening the life of those materials, which means that they're going to have to be replaced sooner, and it's more cost, more waste. So the goal is let's maximize the life of everything that's on top of that attic space. And obviously, if when it goes wrong, lots of issues can arise. Down in the south, you're going to be looking more at kind of the aging of materials is going to be because UV and heat buildup is going to be a bigger problem for you. But up in my climate in the Minneapolis area, it's really a lot about moisture mitigation, which can be very destructive. So those are the types of things we're trying to avoid. So one of the things I like to talk about with attic ventilation is it's a very simplified science, and I like to describe it in a way that it really resonates with any homeowner, any contractor, and I think when you can explain it in a simplified way, then it kind of clicks with people, and it's easier to convey the importance then of why a balanced ventilation system is more important. So I always like to use this example of when you have a window open in your house. What happens if it's on one side of the room? You might feel a little bit of air movement. If all of a sudden then you open up a window or a door on the other side of the room, all of a sudden you're going to feel a rush of air come through. And that's the first principle of airflow in attic spaces at play. When you have both intake and exhaust, you have an inlet and an outlet, you're going to have a lot more forced air movement than if you just have one or the other. Good question on the continuously vented soffits versus the soffits with the bird blocking. I will cover that once I get to my intake slide. So I'll make a note to address that once we get there. But great question. So the second principle of airflow, it's called the stack effect. A lot of us might be aware of this. This is just the principle of hot air rising. So as air heats, it wants to rise. And so within your conditioned living space, it's going to rise towards the attic space. And then once you're within that attic space, it's going to be rising right towards that peak. So when you pair these two phenomena together, you get two different things happening. First, you have your air intake coming in and your exhaust at the top. So that's that inlet outlet, that nice convection effect. So you're taking advantage of that, those cycling air and that convection. Second, you're pairing that with that stack effect. So as hot air is rising, it's helping basically to amplify that cycling of air from fresh air outside into the stale air on the inside, and pushing it out the top. And that's really airflow in a nutshell, and attic ventilation. It's bring in fresh air from the outside, take advantage of that stack effect where hot air wants to rise towards that peak and flush it out. And that's really all the science you need to know on attic ventilation. You can get a lot more technical than that, but really when you boil it down, if you have sufficient intake and you have good balanced exhaust with it, that's really all you need to have a healthy, well-ventilated attic space. So one of the next things I want to talk about, and this is an important concept with attic ventilation, is NFA. For those of you who are not familiar with this term, NFA is net free area. And this is how all passive ventilation products are rated. And it's basically all it is it's just a measurement of the openings on a vent. It's just, it's just a straight number. So whether it's like a static vent, you're just going to be measuring the holes on that box vent or that round turtleback vent or whatever it is. And that's how much open area there is for air to move in and out of. If it's a ridge vent, they usually rate them on square inches for every foot. But it's going to be a square inch rating on how much NFA there is. The reason I like to talk about NFA and bring this up is because there's a lot of misconceptions out there. And I actually tend to see the mistakes and the misconceptions the most down in particularly in Texas and some of the southern markets. Because it's so hot there, and because I think some of the vent manufacturers have kind of taken a strategic approach to say, we're going to kind of promote on higher or bigger airflow numbers there, and kind of not really, I would say, alluding to the fact that the whole system, the balance system with intake and exhaust is just as critical, but instead they just focus on the exhaust vent itself. So what NFA really is, why I like to talk about this is it's not about getting the most amount of ventilation on your roof. That's a critical distinction and ties into NFA. It's about getting the right amount of ventilation on your roof. A lot of times I hear contractors tell me, I use this vent because it has the highest NFA rating. So it's the most square inches of open space, which means the most capacity of ventilation. Now, in theory, that sounds good. More ventilation is better. But again, it's not about getting the most ventilation. It's about getting the right amount of ventilation, because what you want is every different attic space is going to have a different requirement for how much NFA and how much ventilation it needs. And so first, you want to make sure you're matching the amount of ventilation you put to the needs of that attic space. And second, and probably just as if not more importantly, you want to make sure that you're balancing it with the intake ventilation that's there. Because this is probably one of the more common things I see is you'll see a contractor say, I put this really high NFA rating vent on there because it's going to be great venting. All of a sudden that system is far imbalanced and there's way too much exhaust, not enough intake. And so that creates this, you don't have like quite as nice of convection cycles where that fresh air, because when that fresh air comes in, that system is so lopsided that you're not getting that cycling effect that you want. And then what happens is all that hot, stale air just stays put in that attic space. So again, with NFA, the main point I like to keep coming back to is it's not about the most, it's about the right amount.
Are there or not necessarily regulations, but to your knowledge, do all manufacturers list NFA for their roof venting products?
Yes. So pretty much every vent that I have ever seen, whether it's a box vent or whether it's a ridge vent, or a dormer vent, all of them will have an NFA rating. Now, one thing to be cognizant of is there was a prominent study that was done many years ago, and it showed that a lot of manufacturers were misreporting their actual NFA ratings. They were over-reporting them, and a lot of it had to do with they weren't taking into account that the mesh screens that they were putting into some of the vents to keep squirrels and things out, and that it was actually reducing the amount of airflow too. So it's one of those things, like it's just it's pretty hard for any just buyer to verify that of a given product, but it is good to keep in mind that there are in some cases, just because you see like the NFA is, let's say it's 18 inches for every foot, it doesn't necessarily mean that you're exactly going to be getting that. Some other things to keep in mind too is that if you like on a ridge vent, if you cut the slot too small, then that could reduce the amount of airflow. If there's debris clogging the baffles of a vent, that could
But
reduce it to.
three coats of paint on the perforated soffit or adding,
Yeah.
or, the roofers that inevitably are going to tear a hole for their static vents with their claw hammer and just a
Yes.
whole
Yep.
line of.
Exactly. Yep. So there are times when it doesn't, but as far as like when you buy something, the packaging or the product, you should always be able to find an NFA rating, and that is also true for intake products. All intake products have an NFA rating as well. So whether you're installing continuous soffit vents, which again we have a question on that, we'll talk about that, or you're doing the bird blocks, or whether you're doing those rectangular grate vents. Those all carry NFA ratings too. So if you know what brand and what model number you have, you should somewhere be able to find that NFA rating. And that's one of the things I actually find is one of the hardest things is I'll go on a project and it's a re-roofing project, and that intake was installed, maybe 10, 20, 30 years ago. So they have no idea what the product is, and we have to figure out what the NFA rating is. So that's where I have some kind of rule of thumb guesstimates based on what the product is. But both intake, exhaust are all rated on NFA. The one exception is when you have anything powered. Anything with a fan and a motor is going to be rated in CFMs, cubic feet per minute, and how much air the vent moves, and not NFA, because NFA is just for static ventilation. So it's just, again, opening size, but powered ventilation is the one exception to this point.
And that like a whirly bird type of vent would also be a CFM, or it seems like I did some research on them and they have just an equivalency chart. How many?
Yeah, they're the one kind of, I would say, gray area exception where I want to say sometimes they'll rate on CFM, but the thing is if it's not windy and if that turbine isn't moving, then there's really no CFM, and it almost turns into a static vent. So they kind of are careful in how they phrase their marketing pieces and their literature to, I think, like to your point, they do an equivalency. So yeah, so those are I would say an exception to all of this. The good news I feel like is, and I'll talk about why later, but I feel like turbines are kind of going by the wayside, though I still do come across them quite a bit. So it's just they're not used nearly as much as they used to be. So, all right, so balance system. I think you guys have probably already gotten the importance of this, and I've alluded to this many times before, but a balance system, not only is it required by the codes, but it's so critical to any efficient and well-functioning ventilation system. So again, basically, you just want equal parts intake and exhaust. And when you're figuring out what are the number measurements that you're trying to make equal, it's the NFA ratings. So let's say you have 3 box vents at the top and they're each rated 100 square inches. That means there's 300 square inches of exhaust ventilation at the peak. So then you want to make sure that there's 300 square inches of ventilation to allow that air to balance out evenly. And you're usually going to want to split that evenly from side to side. So balance system, that's really kind of what you're aiming for. The codes actually do allow you to go imbalanced. The way the codes are in the International Residential Code, they do say that they allow for a 60%, 40% split between intake and exhaust. So you can actually have a slightly more intake and a little less exhaust, but you can't exceed a 60-40 split. And I actually think 60% is actually, in some cases, I actually recommend that. I think it's good because I think more fresh air coming in and slanting your system slightly towards that measure is, I think, can be more effective and efficient in some cases. But general rule of thumb, shoot for a 50-50 split.
Did they take out? It's still in there though, that 1 square foot for every 150 square foot on the unbalanced. Yeah.
Yep. So
that's just not going. I can't believe that's still in the code. It doesn't seem like that works.
Yeah. Yep. So I agree with you. I think rather than meet the 150 and 1 in 300 rule, if I have no other options, like the first and most important goal anytime I'm designing a ventilation system is make sure it's a balanced system. And then, then you try to meet the 1 in 300, 150 codes. But the balance, just from my experience of what I've seen, is I see more problems arising when there's not a balanced system versus when they don't have enough ventilation, like to meet the 150 number. So I think hit the balance first, and I agree. So I want to so just, this is the kind of the ventilation code. I would say that's referenced in almost every part of the United States. Some jurisdictions may choose to like add additional kind of riders onto this, but this is generally everywhere I've gone, and I pretty much cover coast to coast. Everywhere I've gone, almost every local code just defers to the IRC and this specific code. So basically what the code is, and I'll show you what the 2021 updates are shortly here. But basically what it's saying is, first you have to vent 1 square foot, provide 1 square foot of ventilation for every 150 square feet of attic space. That is kind of the baseline of the code. Now, they allow you to cut that amount of ventilation in half to 1 square foot for every 300 square feet of attic space if you meet 2 conditions. First is if you're in climate zones 6, 7, and 8, so the northern band of the country where you tend to get a lot more snow and moisture is more of a problem, you have to have a vapor retarder installed on the condition side of the roof beneath the attic space. So that's one. If you're outside of climate zone 6, 7, and 8, you can ignore that. But the second exception is really the big one, and this is having that balanced system. And if you have a balanced system, then you can vent to the 1 in 300 rule. And it's just basically make sure your exhaust vents are in the upper portion of the roof, make sure your intake is in the lower portion of the roof, and they're balanced with not exceeding that 60-40 split between intake and exhaust. So I kind of boil that down. It's basically, yeah, so 1 in 150, unless you meet the 2 conditions. First is vapor barrier if you're in the northern climates, and then 2 is you have that balanced system. So it's pretty simplified. In 2021, we just hit a new code cycle, and they more or less kind of kept things the same as they were. They did add this note that vents must be installed according to the vent manufacturer. Now, might seem kind of innocuous, but actually this is pretty important because all vent manufacturers have one clause in particular that they almost always will have, and this says not mixing different exhaust vent types. So this means if you have a ridge vent on your roof as your exhaust, don't pair it with a turbine, or you shouldn't have gable vents with it or powered fans. So that is something to keep in mind as you, especially as you're out and you're talking to people, is we want to be making sure that whenever you're installing whatever exhaust vent product you choose, that needs to be your main and only source of exhaust ventilation, because there's just been too many issues that have arisen when you mix different vent types. And I'll talk about kind of how those happen in a minute. But just know this is kind of the latest update. And really this according to the vent manufacturer clause is the main change for this most recent code cycle. All right, well, I'll tell a quick case study story from my market actually here in the Minneapolis area, because I think it kind of summarizes neatly a lot of the things that I've talked about so far. So this was a project, it was in the Minneapolis metro area, and I got a call, it was early spring, and this building owner had said, he's like, hey, I've been having issues for months, and here's what happened. So it started out midwinter. I'm getting calls from several of my tenants saying that they have water spots in their ceilings, they have moisture dripping down their windows. And so it sounded like there was a heat buildup problem and moisture buildup problem in the attic space. That was his kind of guess. So he sent the building maintenance manager to inspect, and this guy didn't know a ton about roofing, but this guy thought it was okay. There's a lot of heat and moisture building up. I need more exhaust ventilation I need to cut more holes in the roof to let all this hot, moist air out. Well, so he went up and did that, and the problems actually got worse. And so then the building owner says, hey, we need to fix this. The guy goes up there and installs more exhaust vents, thinking, okay, I didn't put enough. And the problems got worse. And so then he thought, okay, I need to get some real air movement going. So he installed some powered fan vents, exhaust fan vents, to draw that air out. And what would you guess? Problems even got worse. So by the time I got called out, then in the spring, they said, hey, we just need a local ventilation person to come out, just take a look at this, let us know what's going on. I walked out there, and on each of this there's 2 buildings, and each attic space was segmented from the rest. So there was a total of 6 attic zones for these 2 buildings, and each attic zone had, I counted up, I had 26 box vents. We had 5 turbine vents, the whirlybirds. We had 3 powered fan vents. And to top it all off, we even had on each roof section, we had a high profile continuous ridge vent all the way across the ridge. Yeah, so I walked out there, and I'm like, I knew exactly and immediately what the problem was. And this highlights a lot of different things I've talked about so far. First is that contractor thought and fell prey to that old adage of more is better and more ventilation is better for your roof. What he didn't realize was he was imbalancing that system so much that he was actually drawing air in from the outside through the exhaust vents, and all that moist and stale air was kind of just being compressed down and held down in that attic space and was not able to be flushed out. So yeah, first was more is better, and he fell prey to that. Second was ignored the balance system, did not even think about the intake. And that was really kind of the crux of a lot of the problems, was it was not a balanced system. And the third problem was he was mixing different vent types. So what actually was happening, and you can actually, I bet if I would have gone out there in the winter, I could have seen this in real time, especially if it was snowing. But what would happen is as soon as one of those powered fans kicks on, it's gonna pull from the closest vent opening to it as its intake source. So in theory, you would want that to be the intake vents down at the eaves, because that's great. And you want to pull fresh air in from the bottom, gets flushed out the top. But because they had all these other vents on the roof, it was actually pulling from the nearby box vents. It was pulling from the ridge vent, and so it was pulling in air. And potentially even we get a lot of swirling snow here in Minneapolis, so I wouldn't doubt that it was pulling in some snow with it too. And the turbine vents, probably once those got started spinning, those probably did the same thing too. So mixing different vent types can lead to a lot of different problems. So again, I love to tell this story because it just highlighted so many different issues. And our solution was, I did the math, did all the calculations, and figured out here's exactly the correct amount of ventilation for each of these attic spaces. And then we ended up specifying a ridge vent to run all along all the ridges. And I specified exactly how many feet of slot to cut for each section. And then what we ended up doing was we opened up the intake vents a little bit because they were kind of a little light on the intake. And to this day, this was probably about three and a half years ago now. To this day, they have not had any issues. And they were kind of dumbfounded when I came back and said, you basically need to get rid of all your vents to solve your vent problem. And they were surprised at that, but have come to find that, okay, we needed to create a balanced system, and we needed to get the right amount of ventilation. And that was the solution. So again, we want to make sure you're not falling prey to that whole more is better. It's about getting the right amount of attic ventilation for your attic spaces. 2 is you want to make sure you're getting that balanced system, equal parts intake and exhaust. And 3, don't be mixing vent types. If you can check those boxes, more often than not, you're going to be okay.
Oh, heck, a few more power vents would have solved the problem.
Yes. Yeah, I mean, they couldn't have opened up that roof any more than they did. I was very shocked when I got up there. I'm surprised they had any more space to put vents, but nonetheless, it happens. So again, it's like some of these things, especially to all these people on this call, you guys all might be pretty educated on this, and you might be shocked that that's happening. But it's like some of these people just don't know ventilation, and that's why we got to do our job to inspect and educate people about the right way to do it. Okay, so now I'm going to talk about just quick talk about the components, and then we'll start doing some application stuff. So intake ventilation, it's going to come in two forms. Majority of the time, it's going to be in the overhangs, and it's going to be soffit ventilation, like in your soffits. There are some cases, and especially actually down in Dallas, I've ran into this quite a bit. There are instances where a house doesn't have an overhang or a ventable soffit, so you actually have to move it onto the roof. And so that is I would say I've run into many applications, and at Quarks, we actually have a specific product that we make and we specify for those applications. So just know that. Oh, go ahead, Jason.
While you have this slide up, this just recently came up in Tyler. And so for any of the code officials that are enforcing, so we love our 5-foot side setbacks here in Texas, right? And so what is on that 5 foot from the property line? It's not the soffit, it's actually the wall. Well, if you look at your fire resistance rating table in the IRC, that soffit actually can't be ventilated at that point. Now, I just always ignored that just because I thought it was dumb. What's another 16 inches? However, if you are in a jurisdiction that is enforcing that, and you're not allowing that ventilated soffit, well, you're creating an inadequate attic ventilation scenario almost assuredly. And I love this product to solve that problem. And I don't know if you were going to mention that or not, but while you had the slide up there, I wanted to make folks aware of that.
Yes, no, I'm glad. I figured, yeah, you and I could talk about that because I remember you guys mentioned that ahead of time. So yes, this is that perfect scenario for, yeah, if you do have those setback requirements and you need to move your intake onto the roof, this is a way that you can do it. And there's a couple different products. We, Quarks, we make one, and there's other products on the market too. And basically what you're doing is you're cutting a slot in your lower third of the roof, making sure that you're above the insulation layer and making sure that it has a straight path, to actually the attic space that's not obstructed. But then you install the vent over the top of it, and you basically then shingle right up over the vent, and it becomes more or less kind of like a starter course. And then that provides the intake to balance evenly with your exhaust.
And Jeremy had a question while you're talking about the 1 to 150, if you want to look at that, or we can hold it to the end, either one.
Yeah, I'll address both questions right now. First, actually, since I'm talking about intake right now, have I seen a difference between continuously vented soffit coverings versus the open soffits with the bird blocking? I would say yes. I tend to see fewer issues with the continuously vented soffit coverings, just because the bird blocks especially tend to get painted over a little bit more. I feel like they tend to get clogged a little bit more too. And I think it's just a representation of, I've tended to see them in a lot older of homes too, the bird blocking, especially kind of style of venting. And at that time, there just wasn't as much knowledge about ventilation. And I think people are trying to do it and are better at getting it right now. So I think it's kind of a reflection of the time things were built and the education that we had at the time too. So it's not to say that the bird blocking can't work or is not quite as effective, but with that in mind, I do think the continuously vented panels, I see fewer issues with them, and I think they're less prone to either being clogged or like blocked or painted over too. So now, yeah, it's again, ultimately, if you get the right amount of them in, that's the other thing too, is a lot of times those bird blocks, they have such low NFAs that sometimes I see a lot of those types of houses are under vented on the intake side. Okay, as far as Jeremy's question, so for the 1 in 150 rule, does that pertain to a ventilation system that only has exhaust ventilation installed? So if there's adequate exhaust ventilation installed according to the 1 in 150 rule, a residential home would be considered adequately ventilated if it didn't have any intake vents. Yes, so my interpretation of the rule is basically if you don't have that balanced system where you're not meeting that 50-50 or the potentially the 60-40, then it's yes, you need to vent to 1 in 150. So for all those instances that you are not able to get to that balance, that is where the code is law. And I think the reason they wrote the code that way is for, again, this type of situation where we're talking about on roof. I think it's because on roof intake vents it's, I would say, more of a newly adopted practice. So I think there was a lot of time and a lot of years where they didn't really have great means to provide intake ventilation. And more often than not, if you didn't have an overhang on your house, they would try to force it into the gables. But I think the code adoption bodies, I think what they were trying to do was allow for some of these exception situations where you didn't have soffits. So yes, if you don't have any intake, then and you just have exhaust, you'd vent to the 1 in 150 rule to meet the code. Now, from my perspective, I would say I would never do that. I would always try to find some form of intake, and I think that's where the on-roof products come in. Because again, I don't think a product without or a roof without intake I think it's going to be a lot more prone to issues than something with just than with like that balance system. So I would always aim to have it. Okay. Bathroom exhaust venting out of the soffit. We have different interpretations of the code in my area. What is your interpretation? That's a good question, and it really kind of varies because I've seen some very conflicting things, and I've talked to different inspectors and different people who have different opinions of this. So I think you're right in that it's a little confusing. Basically, my interpretation, it really depends on what area. So I can't give like a broad statement on exactly like, if it's allowable in a given area or not. Generally, what I will say about it though is I do not recommend it. I think bath vents should always be vented out towards the top of the roof, and it should not be put out the soffit, because back to my point about that the convection kind of cycling that happens with intake venting, when you're pumping that hot air and moisture laden air, especially out your intake vents and your soffits, it's very possible and likely that an updraft can come right up your siding and push all that hot stale air right back up into your attic. So whether the codes are kind of ambiguous or what in a given area, or whether they explicitly rule it out, or whether they completely allow for it, I would just strongly advise don't do it, because I think you are opening the door to having moisture issues in your attic, and it's going to lead to some problems, very likely. So I would say, I can't weigh in on any specific one. Happy to read some specific language on a specific code in your area, but I would just say as a general rule of thumb, people really shouldn't be doing that.
Yeah, and code tells you to take it to outside. It must discharge to the outside. Mm-hmm. Well, to me, if you are going to ventilate it to the soffit, you can't just lay the duct over in the soffit. I think I want a termination cap with a penetration to the soffit. And then ideally, I never even thought about this before, but that's a great idea. If you can get that a few feet away from the intake, I mean, if you had your soffit vents cut every 4 feet or something, maybe you want that right in between a couple. But I never thought about bringing that moist, warm air right back up into the attic, which obviously there's a real good chance of that happening.
Yep. Yeah. So again, if at all possible, vent it up and out towards the peak of the roof. All right, so intake challenges, the most common issues I see out in the field, not having enough of it, just flat out not even putting like enough vents in is a common one. Having it blocked by insulation in the attic is another really common one. Painting over it from the outside. A lot of these issues tied to the fact that the roofer a lot of times was not the installer of it. You know, this was done when the house was built and framed, and so the re-roofer especially is never even going to see that. And what I've been trying to educate a lot more roofers on is, hey, when you're redoing a roof, you need to go check those intake vents and make sure there's enough of them, make sure they're not blocked, and make sure you're designing that the exhaust vents to balance evenly with those. Now, as far as the exhaust vent side of things, so there's a lot of different options. You know, you kind of like the two main options. You have your traditional static vents, and then you have ridge vents. Those are kind of the two primaries, and then you have a couple other options. So I'll quick hit on a couple of the others, and then I'll finish with ridge vents, static vents. Powered fan vents. Jason and I were talking about this at the beginning of the meeting. I try to steer away from these if at all possible, just because there's very rarely will you ever run into an attic space that is perfectly sealed off from the conditioned living space beneath it. There's almost always, there's going to be leaks around the can, recessed lights in that upper level, ductwork running into the attic, that attic hatch, the attic access point. There are always points and spots where moisture and heat can find its way up in there. And so what can happen is, especially if you don't have sufficient intake, once that fan kicks on and starts pulling air out of that attic space, if it doesn't have enough supply to it, it's going to pull from other areas, which means, think about this, it's 110 degrees down in Austin, Texas in the summer. And that attic space is, 130, 140, then you're pulling in cool conditioned air from the living space into that really hot attic. It's going to condense on surfaces, and then you're going to have potentially some moisture problems. So with that said, I try to avoid powered vents. Now, the situations where I think they come into play is when you have really big attic spaces, like we're talking like very large attic spaces, tends to play more in commercial. And then also, if you have spaces that have really high or unusually high amounts of moisture and humidity. In those cases, I have seen sometimes that passive ventilation like box vents and ridge vents maybe doesn't have quite enough, create enough movement to minimize the amount of moisture buildup. So those are the situations where I tend to be specifying those more. But general rule of thumb is I try to avoid these. Now, what I will say, there is a distinction between, because I know down the south especially, there's a lot more solar fans that are installed and used. Those I have much less issue with than the hardwired ones, because the hardwired ones, the CFMs on those and the amount of air they move is a lot higher. The solar powered ones they don't have nearly as much pull as the hardwired ones do. So I've seen less issues with those. So I try, especially when we're talking residential spaces, I try to steer them, if they want to use a powered fan, I try to steer them more towards the solar options. Another one I want to touch on is gable venting. This is, I will rarely ever say that you should never use a type of ventilation. This is, I won't say never, but you should try to avoid gable venting if at all possible. Couple reasons why, back to my point earlier about the stack effect, hot air rising. Hot air wants to rise vertically. When you're relying on gable venting, you're relying on a horizontal ventilation orientation, and you're just not moving air effectively. Also, they tend to be paired with other types of vents like ridge vents or box vents, and you can create this short-circuiting effect where you're not having that clean exchange of air between your intake and exhaust. So gable end vents, if you want to keep them on the outside for decorative purposes, by all means do that. But I always tell contractors, just when you're redoing a roof, plug them up from behind and just put on any one of these other types of vents. And then that leads me to box vents and ridge vents. Both have their time and their place. I think they both can be effective. I would say I tend to see less issues on the ridge venting side, but I think there are times and, when some might be better than others. The reason I like to, steer towards ridge vent is just because you're venting at the highest point of the roof. You're getting continuous ventilation across the space versus, like zonal ventilation with sometimes the boxes are scattered across the roof, and then you're getting these hot zones where you're not getting quite as much ventilation. So continuous ventilation, and you just get better curb appeal too. So I usually steer people towards ridge vent, and I would say more of the industry is trending towards ridge vent as kind of the predominant option. Main exhaust vent challenges I see, mixing different vent types. You already talked about that, can create short circuiting, overloading it, having way too much of it, not installing per the manufacturer's installation instructions, and ultimately like ignoring the intake vents and not having those balanced systems. Okay, so now I want to kind of jump to, I'm going to quick jump to just some kind of in practice, like on the job, actual kind of things that I look for, and especially some principles that I incorporate when designing. So first thing is locating vents. Always just put them as high on the roof and high in the attic space as possible. Second thing, know where your attic zones are. I'm running into more and more builds and homes now, especially these newly constructed houses that have multiple attic zones. It used to be pretty simple. You had these old school, these gable style roofs where it was just one attic space spans the length of the house. More and more, I'm seeing these cut up roofs, and I'm having to train contractors to say, go check where the attic spaces are. Because a lot of times contractors say, I'm just going to throw a ridge vent on every single ridge, or I'm just going to throw on box vents evenly across the roof. I'm like, a lot of cases, you might have a cathedral ceiling there, and you might not even be venting anything. I've solved many problems by just like showing them where the attic spaces are and showing them that they weren't venting in the right spaces. So know where your attic zones are. When you have multiple ridge elevations, the rule of thumb here is you only want to vent on the highest ridge within the same attic space. So like this roof, for example, if this was all one attic space, you'd only want to vent on the highest point. But if these are separated attic spaces, then that's when you can vent on multiple ridge elevations on the same roof. So just make sure, again, you know where the attic spaces are and if they're the same or not. Because what can happen is if you vent on multiple ridge elevations within the same attic space, it's very possible that that lower ridge will start to act as intake for the upper, and then you're just kind of short circuiting that system, and then the intake vents at the eaves kind of become ineffective. So make sure.
While you have that picture up, one thing I'd written a handful of red text for and it's seen quite often is you will have like in your picture there, that little front room behind the palm tree that's kind of separated where the ridge dies in. So if a lot of times if you have isolated attic sections that are completely isolated like that, I mean, I would assume that's a vault ceiling in that room or something, but imagine that's a flat ceiling. Those isolated attic spaces, a lot of times you'll see it with foam houses as well, where the attic space above the garage, they've got the pony wall at the garage to house intersection, that's all foamed. Well, any of those isolated attic spaces need to be ventilated as well. And a lot of times you'll see roofers miss those.
Yep, that is very true. Yeah, they just assume, okay, it's the main one up here. Goes back to my point, know where your attic zones are, because yeah, that's its own roof and its own attic space to be vented. So do the math specifically for that and design and install your vents accordingly. No, this is kind of back to your attic zones area, but know where firewalls and draft stops are, and any other obstructions too. Like this was a project I did down in Houston for a big multifamily complex, and from the outside it looks like it's one big attic space, but this actually ended up getting, because of codes, got broken up into a bunch of different attic spaces. So what I actually had to do was I treated these almost like they were their own separate roofs, and I had to do the calculations to figure out how much space does each space have, and then orient the vents accordingly, and locate them as high in these spaces as possible and pair them with the intake that was available. So just again, it goes back to know the spaces that you're venting. Cathedral or vaulted ceilings, There's two different ways you can do these. One is you don't have to vent them. Per the codes, you actually can do these as sealed off assemblies. From the research that I have seen, just kind of from my experience, I think it's better to vent these. I think it's a good cautious and protective measure. So this is kind of the detail on how you do it. Basically, what you're doing is you're creating an air cavity between the decking and your insulation layer. Now, the codes say that you need a minimum 1 inch of airspace. I can tell you from experience, and also just from the researchers who have done some studies on this, is you really should be aiming for 2 inches. 2 inches, because 1 inch is not going to cut it, especially on a longer roof. Or like a taller roof, like this one, it has intake on this lower third. If you only have an inch cavity, it's going to get compressed at some point, and you're probably not going to be getting air to flow all the way from the lower to the top. So basically what you're doing is, you take those baffles, a lot, it's the same as the baffles that you'd see in a traditional attic setup, where you're holding that insulation away from the roof deck, and you'd install those up the roof. So a couple points to note with this, in this design. First is, you want to make sure that you're venting every single rafter bay, because each one is kind of its own space to be vented. They're not, because of those, because of the truss structure, each cavity is blocked off from the next. So you need to make sure that you're venting each rafter bay. Second, you want to make sure you have continuous intake and continuous exhaust. Because if you have like box vents, let's say, or if you're not cutting this ridge vent all the way across, there's going to be certain cavities that either don't have an inlet or an outlet for air. So this is why I recommend always ridge vent in these applications, because then you're getting venting in every cavity. So that's kind of how cathedral or vaulted ceilings are typically handled. Again, otherwise the codes do allow, if they don't vent these, that is allowable too. And that's just, you got to make sure you're sealing it up right and using the right vapor retarder.
Your interpretation of that, I think it's, 806, talking about the continuous insulation for condensation control and an unvented roof assembly. Is it your understanding that if were that picture that you have on the screen there, if that were unvented, you would actually have to have a continuous, depending on climate zone, a layer of continuous insulation? Is that how you interpret it?
Yeah, that is my interpretation of it. Yeah, you're right. There's the climate zone dependency, I think, too. That would come into
I can
play. Tell
you, unvented roof assemblies, that continuous, I believe it's R5 in our climate zone. Mm-hmm. That it's never enforced. It's just flat out ignored all the time. It's a shame. But anyway, go ahead.
I will say I've kind of seen the same thing too. It's a lot less enforced. So I agree. That's kind of been my experience too. So yep, so that's cathedral ceilings. Now I want to talk about a couple specific to the south and heat. Just some instances. These are some ventilation design projects that I've done. For most of these are re-roof applications. This is a straightforward, simple one where they were having, their shingles were curling. What had happened was they had this short ridge in the middle. They didn't have enough intake. They had a lot of exhaust because all of this E footage was vented. So what was basically happening was they were kind of, the exhaust was a bottleneck in this situation, and they just did not have enough exhaust venting to pair with the intake. And so all of the heat was not escaping as effectively. So this is one where we did the math, figured out, okay, let's get this exhaust in balance. And we were actually able to help solve the heat buildup problems. Again, just by getting the right amount of exhaust. You actually will note we did vent on the hips here, which can be done as an exhaust venting method. Basically, some ridge venting products on the market can actually be installed on hips. So this was one where we didn't have enough ridge footage to work with. Clearly, from the previous install, we found out that was insufficient, so we needed more. So what I did was specified it on the hips to get them the proper amount of ventilation. It balanced them with the intake, and now they haven't had any problems. So common scenario, try to help them create a balanced system. Another one, this was a Dallas project. This was a very difficult intake in exhaust balance situation, just because of this house was connected in the middle. It was kind of like two different ridge sections. So what happened was you don't have intake on both sides of the roof. So it's kind of a unique roof layout that caused some issues. So what we had to do is figure out exactly how much venting do they have in these on the eaves and for intake on each side, and kind of pair that up and then figure out, what's the attic space, and then pair that up evenly. This was a scenario where, actually tell them, don't cut a slot all the way along the roof. Like, we can meet the ventilation code for the 1 in 300 rule, and we can still balance with that intake. But this is one of those situations where you do not cut your slot all the way across the ridge, because what's going to happen if you do that is you're going to over vent on the exhaust side, then you're going to have an imbalanced system, and it's not going to be working as effectively. So I would say a common mistake I see is that ridge vents are when ridge vents are used, they always cut the slot all the way along the ridge. And just know that there are situations where you actually aren't necessarily going to want to do that. So this was kind of a solution to this kind of unique roof layout situation. This one was a project in Austin. They had very little ridge vent space to ridge to vent on. You can see this roof is almost all hip. And even if you would have done hip venting, it still couldn't get us to the correct amount of ventilation for that attic space. So the homeowner said that they wanted to use solar powered fans. And so I kind of worked with them along with one of the solar powered manufacturers to figure out, okay, this was a scenario where they have very little space up here at their peak of their attic space to put a lot of box vents or put, any ridge vents. So this was a scenario where we were able to get the right amount of ventilation. And actually, this was kind of a candidate for the powered ventilation, and the contractor and the homeowner kind of drove that decision to go to these solar fans, but I kind of did the math and worked with them. So this was a situation where, because of space and layout, it kind of made a little bit more sense to do something powered. This was another project in Dallas where this very complicated roof, very unique roof layout. This was one where they had no overhangs and no ventable soffit. So this was actually one of these situations where we did that on-roof intake venting. And what we did was we did the math and figured out each space to be vented, because this was a cut up roof, several different attic zones, and provided the intake in the lower parts of the roof, and paired it up with the exhaust venting on each roof section. So again, a scenario where didn't have the air intake space, so we actually did the on-roof intake to balance with it. All right, so I will wrap it up with just, again, one thing I like to say is there's no one size fits all solution for ventilation. Basically, as you can kind of see from some of those diagrams and designs, is every roof is different. Every roof has different requirements. Every roof has its own unique kind of qualifications that are going to make, certain venting products or certain venting amounts like more or less needed. So you just take it on a case-by-case basis and specify a balance system, get the right amount of ventilation, don't mix the vent types, and then you can solve the majority of the problems you're going to have. So with that, I want to open it up for any questions that people might have. It doesn't look like I have anything in the chat. So does anybody have any questions on anything we talked about, or maybe anything we did not cover related to ventilation?
And I know, I bet you we've got, I have let's see, actually, I've already asked all the ones that I had written down. So, and just as I know, back when I was still doing inspections, attics are always hot in Texas in the summer. but it's a noticeable, a lot of times you can pull down that attic stair and tell quite literally from standing in the garage at the base of the attic stair, when you get blasted with that 15 or 20 degree hotter air than it should be, double check your vent. I mean, because I've seen it so many times that it's like, man, it's awfully hot in this attic. Yes, it's always hot in attics in Texas, but when you're in one and it's, I mean, you should be checking every house for proper balanced attic ventilation. But when you notice it being unusually hot in an attic, to me, that's a sure sign. We did have one question come in hot areas like Texas, what are the effect on shingles when there is a lack of ventilation?
Yep. So what it'll do is, because the shingles are like it's an organic asphalt in most cases, it bakes it a bit, and when that's heated excessively for a long period of time, it prematurely ages them, and that material wants to crack a little bit more. So it actually is. So that's kind of how it will shorten the life. And then usually what you'll see is they a lot of times will start to curl, or just they just crack over time. But there is a reason why all shingle manufacturers have it as a condition of their warranty that you have to have a properly vented attic space, and it's because they know it shortens the life of the shingles. So that is the reason why they require that. Jeremy, to answer your question, so I will tell you about our product. It's for the on-roof intake. We call it the Quartz off-ridge vent, and it can be used in that. What I will say is I know a lot of the big vent manufacturers that I want to say, like GAF, Air Vent, and others also, Owens Corning, also have their own intake vents. So I don't want to just push ours, just know that all of them have their own products as well. But ours is the Quartz off-ridge vent, and is probably one of the more common.
And Nick, I would love for you to so I was teaching a class in Beaumont, Texas, down on the coast. I mean, really high dew point. And anyway, it was talking about underventilated attics, it's the problem, blah, blah, blah. And one of the guys, I mean, I had probably 60 people in this class, and one of the guys is like, man, my HVAC boots used to sweat like crazy, and the problem was my attic was over ventilated. I went in there and clogged up all my vents, and man, they quit doing that. And the hotter air can hold more moisture. If you do make your attic hotter, yes, you can help reduce that, but you're way better off with balanced ventilation. More than likely, if you're HVAC, just any comments generally, Nick, on HVAC boot sweating at the drywall? That's typically, that's a ventilation balancing problem most of the time, just like in your case study, correct?
Yeah, because I totally see what Rick is, or I know Rick put in the questions, but yeah, I have run into those situations too. And they say, hey, when I blocked up some of the box vents, it actually helped with that. I think a lot of those cases, when I've run into this in a few times, it's been because they didn't have enough intake, or it wasn't a balanced system, so they weren't getting those air exchanges. Because back to your point, Jason, an attic is always going to be hot. Like it's an enclosed space, so it's going to be warmer than it is outside. Like there's no way of avoiding that. But really what you want to be doing is at least exchanging the air, at least a cup, regularly. So that way you're bringing in that fresh air, and then you're preventing that attic space from elevating to levels that are far in excess of from the outdoors. So again, it could be happening with continuous soffit venting. First place to look is how much exhaust is paired with it, how much intake is there being provided, are those in balance with each other. So that's the first place I start. One thing I will say about attic temps, so to the point of I think what is the proper temp at night you would find acceptable. What I always tell people is, you know your attic will be venting properly or is venting properly if the temperature in your attic is dropping and rising throughout the day as the sun goes up and the sun goes down. Now, it's going to, it's going to lag behind the outdoor temperature, and it's going to lag behind the sun going up and down by usually, maybe an hour, maybe two. But generally, that tells you that, over time, it's following the outdoor ambient temperature because that fresh air from the outside is coming in and replacing that hot air in the attic. Where I see problems, or where I can usually tell you, hey, your attic isn't venting properly, is because the sun will go down and that attic space still stays really hot through, for several hours and into the late into the night. So it's more the cycling you want to see. I usually think, there's not a hard and fast number on it, but your attic space, I generally see, healthy attics are going to be somewhere between, 5 to up to potentially 20 degrees warmer than it is outside, just depending on climate and sun exposure and color of your shingles and all that. And even insulation plays a big role in that too. But it's when you start maintaining regular levels of, let's say 15 to 30 degrees above the outside, and it doesn't fluctuate as the sun comes up and down. That's when I know, okay, the air isn't cycling from indoor to, or from outside to inside, and it's just getting stuck in there. And that's when I can say, okay, we need to look at this attic ventilation situation.
And one thing to double check on that continuous soffit venting, Rick, just because the soffit's continuously vented, what happens when you've got a 10-inch baffle in every 5th rafter cavity and a bat stuffed in the other 4? That continuous, the soffit's continuously vented, but the effective net free area feeding into the attic from that soffit vent might be inadequate. So that might be another thing to check.
Yeah, good questions.
Well, awesome, Nick. Thanks so much. Really appreciate it. I mean, I know, like I said, I've written a bunch of red text for it. We see underventilated or imbalance in the ventilation of our attics. Now, as code officials, we're probably not going to get net free area documentation on the paperwork at plan review, but use some common sense when you're out there in the field and you're looking at a 2,000 square foot house and it has 3 static vents on it. Well, continuously vented soffit and 3 static vents, we might have a balance problem. I just kind of eyeballed it. And I mean, yet you're certainly, as the authority having jurisdiction, you can request those ventilation calculations. That certainly, could be required. But.
Yep.
Yeah, I mean, I just increasing the temperature of your attic, it just isn't a good solution. I mean, I think you're looking at air sealing around your boots, a better insulated boot, and balanced ventilation. But if those don't work, I mean, I don't live in a super hot, humid area. I mean, it's hot in San Antonio, but it's not super humid. And I've heard enough stories from down along the coast that lead me to believe that there's some more challenges to deal with there, and perhaps it's not always an easy answer. Right. Well, thanks for joining us, everyone. Thanks again, Nick. And you see Nick's contact information for his company there. And will you email me a PDF of this presentation so that I can send to everybody?
Yes, yeah, I'll definitely send that. And my email will be included. So feel free to share my email too. I always always happy to just chat ventilation with anyone and be a resource and answer any questions I can. So please don't hesitate to reach out directly to me anytime, and I will be more than happy to help.
Awesome. Sounds great. Thanks again, everybody. And we will see you for another webinar soon. I'll be doing changes to the 2021 commercial in the next few weeks. I'm working on that presentation now. So thanks again, Nick. Thanks again, everybody. We'll see you later. Bye.
All right.